Hi guys, hope you are fine. Me too, I'm fine. So let's tackle this question, guys. And first of all, we read it. A metal heated to 235 degrees centigrade cools to 130 degrees centigrade in 10 minutes. When put in a room maintained at constant temperature of 25 degrees centigrade, find the temperature of the metal after 45 minutes. Apply first order differential equation to solve the problem. So guys, as we start this, let's look at something. We are told of a metal. Let's say this is the piece of metal we have. And this metal we are saying it is at 235 degrees centigrade. And it is now cools to 130 degrees centigrade after 10 minutes. When put in a room maintained, and this room we have 25 degrees centigrade. So now guys, what happens is that this metal, because it's left in the open, it will continue to lose heat. And we see that after 10 minutes it has lost, or it is now 130 degrees centigrade. And so it will continue to lose heat until it now becomes the same as the room temperature. And so that one takes time. And so guys, here there is a rate of change of temperature, which is going to be dt all over dt, that is time. And that's what we are going to expect with this metal. Until now it will arrive at 25 degrees. It will continue to lose more heat. And that means that this metal will now be at room temperature after some time. But now guys, we are asked, what about after 45 minutes? And that's what we are now going to look at, knowing that it is losing heat with respect to time. That is, there is a change in temperature with respect to time. So guys, we start off. So we will say that dt, that is capital T all over dt small t, is proportional now to the difference in temperature, that is T minus R, where R is the room temperature. So that is proportional, because as the difference now, as the time passes, the difference will now be becoming smaller and smaller. And so that is the equation we use now. But now the equation that is used, we call it the Newton's law of cooling, gives us dt over dt is now equal to a negative constant k. You now multiply by t minus r. So that is the equation that we are going to use to solve this problem. So guys, let's now dive into the problem proper. So I will now put dt all over the dt. This is now k t minus, not minus, but plus k r, like that. So guys, from there I can bring, this one is negative, I can bring now dt here all over dt, that is small t. This one now plus, here I put k t. This k is the coefficient of heat transfer. Now this is equals to k r, like that. And the r we know is supposed to be 25 degrees. So I will now be writing r as 25 as we continue. So indeed I can even write it here. I write dt all over dt, this plus kt equals to 25k, like that. K is the heat transfer coefficient. So guys, from there now, we are going to form, already we have formed a first order differential equation. Guys, you can compare this with dy all over dx plus k y is equals to q. You can see this one is similar to that. So the principle we use here is what we call integrating factor. So the integrating factor will be equal to, for this case it would be k, for this case it's going to be k, e raised to k d, that is integral of k dt, like that. So this one will give us e raised to k, integral of dt is t, so this one is going to be k t, like that. So guys, from there now, we come and multiply the integrating factor throughout. So integrating factor, kt, we multiply here, dt all over dt plus kt, like that. This is equal to, multiply again here, 25 k multiplied by e k t, like that. Guys, from there now we come and, before we continue, we look at this. These guys, these are brought about by d all over dt integrating factor, which is now e raised to kt multiplied by y, which in our case is t, like that. So guys, if you were to do this, differentiate this, you will get this. You can use the product rule and you shall find it will come to this. And this other side then is going out to be 25 k e raised to kt, like that. So guys, from where we come and differentiate and integrate both sides with respect to t. So we integrate this side with respect to t, we write here dt, and we integrate this side with respect to dt, like that. So when guys we do like that, this side is going to be e raised to kt t. This is what is now going to be for this side. Because remember that for us to be able to come here is because here there is a differentiation. And you know, integral is the reverse of differentiation. So it's like we are now reversing this differentiation to come back to our original value, which is e raised to kt multiplied by t. This one now is going to be equal to, we integrate this side. If we integrate this side, we are going to have 25 k e raised to kt all over k now plus c. So that's what we are going to find for that on that side. So guys, we can now be able to cancel the k. So we are left with the e raised to kt, then we have t. This is equal now to 25 e raised to kt plus c. So guys, we have two values we are going to look for. We're going to look for c, we are also going to look for k. So for us, if we say now t equals to 0, at that time, our temperature is supposed to be at 235. That is 235. So guys, we can even come and say this. We can put something like this. We can say T0, where 0 is represented by the temperature. This one gives us 235. So we can come and now replace here. So if we replace here, we shall have E. Then this one is going to be, T is going to be 0. So this one is now going to be 1. That is going to be 1. And so we are going to be left with the T there. And our T is 235. So we write this one 235. This is 235. That is our T, 235. So we have here 235. Because this one is 1, then this is going to be equal to, here we have now 25. Because this is going to be 0 and this is going to be 1. Now plus C. So when we do that, guys, our C then is going to be 235 minus 25. Which now is going to give us 210. So guys, our C is going to be 210. So our equation then is going to be equal to E KT. This is the equation. Then we have T there. It's equals to 25 KT plus now 210. So guys, we are going to use this equation. But remember, we still have a constant, which is K. So for that constant, we are going to use now the T equal to now what we had here. This is a question. T at 10 minutes. So I write here 10. This one now gives us 130 degrees. Like that. So guys, for us to find the K, we now come and replace our time here. This is the T is 10 and this is the temperature. So we are going to have E raised now to K, and that we have 10. That is the time, and then we have the now K, which we are looking for. And the T, our T now is going to be 130. Like that. This is now equal to 25 KT. So this one is 10K plus 210, like that. Guys, we forget that here there was E. Here we have E. So what is raised to KT is actually E. So remember, here we have the E. E is the one raised to 10K. So guys, sorry for that mistake. We continue now, guys. We bring now this value to this other side. So we shall have E raised to 10K, like that. And then I write 25 here. Maybe let me write 130 first. And then I come and write now 25. Because here I have factored out the E raised to 10K. I brought 25 this side, but factor out E raised to 10K. Because remember that I have said this is the E raised to 10K. This one now gives us 210. Like that. So guys, we continue. From there now, guys, we shall see that E raised to 10K is equals to 130 is not equal, is multiplied by 130 minus 25, which is now, this one comes to 105. 105 is equals to 210, like that. And so therefore, e raised to 10k is equals to 2 now. Because when you bring 105 here, it cancels, it will be left with 2. So guys, to save on time, I've already done it for you, but let me just explain it to you. So we have found here that e raised to 10k is equals to 2. Then we can come and now guys, we apply natural log. You apply natural log here and bring 10k here, the natural log will cancel with e. So we are left with 10k equals to the natural log of 2. The ln of 2 is 0.693 and here we have 10k. So if I divide by 10 here and by 10 here, I will get this value. So our k is that value. Now, we now come and now use our original equation, having replaced, guys, the k. The k now is supposed to be 0.0693 and 0.0693 in this side. So that this is our equation, guys. Now we come and apply, because all the constants have been solved. We've been able to find all the constants. That is the 210, which was c, and also the k. Now we come and apply our time here, because we are told, we are asked to find the temperature of the body after 45 minutes. So, and that's why we have it here, guys. So we come and now apply this equation. We put now the temperature to be 45. The time, and this is the time, this t, we put as 45. So when we put 45 here, guys, we're going to find this is going to be 3.119. That is, guys, if you multiply this by the time, that is 45 degrees, you are going to find, I've already multiplied here, guys. You can see now 45 multiplied by 0.0693. It's going to give us 3.118, which is approximately 3.119. And so, guys, after putting that, we are going now to bring this e on this side, so that we will have t is equals to that divided by the e raised to 3.119. So guys, when you do this, that is e raised to 3.119, you are going to find it is 22.624. In fact, we can do that. E raised to 3.119, that gives us I made a mistake. That is 3 raised to let me correct. 3 raised to 2, that is 3. E raised to 3.119. That gives us 22.62, and that's what I have written here, guys. So this is 22.1.624 plus 210, and this side is also the same. So finally, guys, when you do that, you'll get this as our temperature. This is now going to be our temperature, guys. And so thank you guys for listening to me. Bye bye.